Hello and welcome back to the notes for Math 050. This is a section over integers as exponents. So this is 10.1. And what we're going to be talking about is we're going to tell the meaning of an exponential notation. Okay, we're going to be able to evaluate exponential expressions with exponents of 0 and 1. We're going to evaluate algebraic expressions containing exponents, use product rule, quotient rule with like bases. Okay. And we're going to express an exponential expression involving negative exponents with positive exponents. So to talk about what an exponent is, exponential notation, this number here is the base, okay? That's the A value, okay? That's the big number, okay? The n is the exponent, okay? And that's my little number, okay? So my little all right, my little number. All right, so now remember what an exponent does. If I were to have something like 2 to the third power, then that means that I'm taking 2 times 2 times 2. Okay, so the exponent tells how many times you're multiplying the base by itself. Okay, so let's write that, all right, over here. And I'm going to put this here. Okay, the exponent is how many times you multiply the base by itself. You multiply the base by itself. Okay. All right, so now let's go in and let's talk about some of our exponent rules. Okay, so we have 3 different rules here. We have the product rule, we have the quotient rule, we have the negative exponent rule, and then we have the 0 exponent rule. All right, so let's go through and let's talk about the product rule. All right, so what I want to do is kind of introduce this and say, okay, let's say that I have 3 squared times 3 to the 4th power. Okay, and when I do that, I want to be able to write this as a single exponent, or a single number raised to an exponent. Now, in order to do this, I kind of have to introduce this idea. So if I have 3 squared, that means that I'm going to do 3 times 3, okay? And then, if I have, say, 3 to the 4th, that means I'm doing 3 times 3 times 3 times 3. Okay, so my 2 is represented here, and then my 4 as an exponent is represented here. Now the question is, how do I rewrite this as a single base raised to an exponent? And I have how many? I have 1, 2, 3, 4, 5, 6. So I could write this as 3. Let me do this. Let me change colors. Okay. Let me write this as 3 to the 6th power. Okay. And I'm just going to leave it like that for now. Okay. Now let's think about this using variables. All right. Let's say I have x to the 3rd, all right, times x to the 5th. All right. And what that means, all right, for x cubed, x to the 3rd power, that's going to be x times x times x. Okay, that's my x cubed, all right, and that's my 3 right there. And then I'm going to do x to the 5th, so it's going to be 1, 2, 3, 4, and 5. X is multiplied, all right, so here's my 5, and I've got 5 of these multiplied by each other. Okay, so how many total do I have? All right, so the question is I'm going to write x to the what power? All right, and so I've got 1, 2, 3, 4, 5, 6, 7, 8. okay, and that's going to give me x to the 8th. Now, my question is this, all right, I don't want to have to do that every time, okay, but notice something. How do I get, what's going on between 2 and 4 to get 6? What's happening between 3 and 5 to get 8, all right? And so what we think about is this. It's like, all right, well, wait a second. I'm doing 2 plus 4, all right? 2 plus 4, and that gives me my 6. Think about it over here. If I take the 3 plus the 8, oh, I'm sorry, 3 plus the 5, okay, that's going to give me 8. All right, and that's always going to work. All right, so our general rule that we have is that if we multiply two numbers with like bases, then what's going to happen is we're going to add our exponents. So if I have some number a raised to the nth power times that same value a raised to the m power, then what I would do to simplify this, instead of writing all this stuff out, what I would do is I would simply add my exponents. I'm going to do a to the n plus 3 power, or I'm sorry, n plus m power, okay? And that's my rule. So when we're multiplying these, the product rule means that we want to add our bases, or add exponents, okay? So add our exponents. Okay? All right, so then let's talk about the quotient rule, okay? Quotient rule, let's look at something similar. Let's do, say, 4 to the, say, I don't know, 6th power divided by 4 to the 3rd power. Okay, and when I do this, I'm taking 4 and I'm multiplying it by itself 6 times. So 1, 2, 3, 4, 5, and 6, okay? Now, if I have 4 to the 3rd power, I'm multiplying 4 by itself 3 times. So 1, 2, and then 3. Now, let's think about it. If I look at each of these parts here, okay, 4 divided by 4, you know, when I do that, 4 divided by 4, okay, 4 over 4 is equal to 1. All right, so if I do that for all of these, this is going to divide out to 1. 4 divided by 4 divides out to 1. 4 divided by 4 divides out to 1. And so what you're left with is this. You're left with 4 times itself 3 times, which is going to give you 4 to the 3rd power. Okay, and that's my answer. All right, let's think of using this with variables. All right, so let's use a different variable here. Let's use, say, the variable y. Let's say y to the 5th divided by y cubed. All right, so y to the 5th means that I'm going to do y times itself 5 times. So 2, 3, 4, and 5. Divided by itself, so that's, okay, divided by y cubed, so that's 1, 2, and 3. Okay, my y's divide out here and here. Y divided by y is 1, so y divided by y is 1, and this divides out. So you're just left with y squared, okay, as a result. All right, and so let's think about it. How am I using the numbers 6 and 3 to get 3? And how am I using the numbers 5 and 3 to get 2? All right, so what I got to think about is this 3 comes from me doing 6 minus 3, all right? And that's how I get my 3. Here, I'm doing 5 minus 3 to get my 2. Okay, so let's think of a general rule, all right? So we're just subtracting these. So same kind of thing. If I've got, you know, say some number a to the n, okay, divided by a to the m power, okay, then what's going to happen is I'm going to subtract my exponents, and this is going to be a to the n minus m power. All right, and that's our general rule. So when we're dividing these using the quotient rule, that means that we want to then subtract our exponents. All right. All right, sorry for my handwriting, but still the app hasn't been updated yet, so we're waiting on that. Okay, now let's talk about the concept of a negative exponent. Now what I want to do is this, all right? Let's think about, doing this. Let's say I have, let's just jump right to variables here. Let's say I've got x to the third power divided by x to the fifth power. Okay, and when do I do this? Let's multiply it out. So let's do x times x times x divided by n, 2, 3, 4, and 5. Okay, when I divide these out, x divided by x divides out to 1, x over x is 1, x over x is 1. Okay, so what you're left with here is you're left with actually a 1 in your numerator, okay, because all those divided out, and so you have a 1 divided by x times x, okay, which is going to end up giving us 1 over x squared, all right? And let me write that so it's a little bit neater. Okay, so x squared, all right, and that's my answer. Okay, now let's do this same problem using our rule for exponents, okay? And so let me come in here and let's write x to the third divided by x to the fifth, okay? And so if I were to do this, okay, I would take my 3 minus 5, so I've got x to the 3 minus 5 power, and that's going to give me x to the negative 2. Okay? Now the question is that I did this problem doing two different methods, okay, that we had just learned about, and I'm getting two different answers. But the realization that we need to have here is that these things are the same thing. All right? So kind of the rule of thumb for this, for the negative exponents, is that if I had x to the negative 2 power, okay, that's going to equal 1 over x squared. These mean the same thing. Okay, and kind of my rule of thumb is this, all right? All right, so that's an equivalent statement, all right? And what I do is this. I say, okay, if I have, say, x to the negative 2, what I do is I say, okay, I'm going to take this whole thing, I'm going to put a 1 down here, and I'm going to move it down into my denominator to make it positive. And so that's kind of what I think of. I leave a 1 up in my numerator, and then I write over x squared to make it positive. Okay, and the same thing would work the other way. So let's write a general rule for here, okay? And this would be a to the negative n power, okay? And that would equal simply just 1 over a to the n to make it positive. Okay, and we always write our exponents with positive values. All right, so then let's think about something, okay? So here's a general rule. All right, this would work for anything. And then let's say I had 1 over a to the negative n, okay? That would just simply be moved up into my numerator, and that would equal a to the positive n over 1. Okay, and that's my general rule for those. Okay, all right, let's talk about the zero exponent. Okay, and I want to do the same type of thing. All right, let's do this. Let's do x to the third power divided by itself, x to the third power. All right, now I kind of already know that we're going to get 1 as a result. All right, here's why. When we multiply these out, x times x times x divided by x times x times x, then my x's here are going to divide out. X over x is 1, x over x is 1. So you're left with 1 divided by 1, which is equal to 1. All right, and if you just think, you know, something divided by itself is always just going to give you 1. Now let's think about something else. All right, now if I do this, let me do the same problem, x cubed over x cubed. All right, let me write that cubed out good. Okay, so then what I would say if I were to subtract my exponents like we just learned about, this would be x to the 3 minus 3 power, which is going to give us x to the 0 power. Well, wait a second. All right, I didn't get the same thing. But the conclusion that you can draw from this is that these are the same thing. Okay, so the statement that we can say about this is this, all right, that if I take anything raised to the 0 power, I'm going to get 1 out of that. All right, so my rule that I would write is if I have some number a raised to the 0 power, I'm just going to get 1, and that's the idea. All right, so pretty easy when you see those. I like seeing those because I know it's just going to be 1. Okay, now here's the other thing. If I just have a single x, okay, so let's talk about up here with this. I'm going to do an exponent of 1, okay? Every number that we have has an exponent of 1, okay? Exponent of 1. So if I have x, that's really the same thing as me saying this is x to the first power, okay? Same thing if you just had the number, say, 7, okay? 7 is really the same thing as me saying 7 to the first power. All right, so that may trip you up if you see something like that going further on the assignment, okay? All right, so now let's do some of these, all right? So, and these aren't that terrible. We do have quite a few problems, but I just want to make sure that we, you know, are able to have enough examples for this. So what I want to do on this one is just simplify these, okay? Now when I see this, I see just x to the first power, okay? And that's all I've got. So when I rewrite this, I'm just going to do x to the 1 plus 8 power, okay? And that's going to give me x to the 9th, and that's my answer. Okay, pretty simple. Okay, over here, I've got m to the 5th times m to the 10th times m cubed. So instead of writing all those out, I'm just going to do m to the 5 plus 10 plus 3 power, and that's going to give me m to the 18th power. Okay, and that's my answer. Okay, over here, okay, this one's a little bit different. All right, I've got 2 different variables. Now, I'm multiplying all these things together. And what I want to do is rewrite this. So I've got put my a's together. So I've got a cubed times a cubed, okay, times b squared times b to the 5th. Okay, so what I want to do is I want to combine these two first. All right, so I'm going to have oh my gosh, this is so difficult to write, a to the 3rd plus 3rd power times b to the 2 plus 5 power. So then what I'm going to get is I'm going to get a to the 6th power times b to the 7th power, and that's my answer. Okay? Okay, over here, all right, I've got 4y. Now this is where it gets a little tricky, and we'll kind of learn about when we have a bunch of numbers raised to an exponent and what that is, okay? So what I have is this quantity, 4y to the 6th times 4y to the 3rd. Because I have a common base, 4y, I can write this as my base 4y raised to the 6 plus 3 power, which is going to give me 4y, that quantity. You've got to make sure we put these in parentheses, to the 9th power. And that's my answer. Okay. Okay, that's good. We're good on that. All right, let's jump down to over here. Okay, similar problems. All right. X to the 8th over x, this is going to be x to the first power. So this is just going to equal x to the 8 minus 1 power. All right. So that's just going to give me x to the 7th. All right. And I'm going to circle that up. Okay, so that's that answer. Okay, this one, because I have a common base of 3t, I'm just going to subtract my exponents. All right, and so this is going to give me the quantity 3t to the 12 minus 2 power. So this is going to give me 3t raised to the 10th power. And that's it. Okay, we don't need to go any further. Okay, on this one, all right, this is going to give me, so let's do this. I'm going to do the p's first. All right, so I look at the p's and I go, okay, I'm going to do p to the 5 minus 2 power times q to the 7 minus 5 power. All right, and what that's going to give me then is just p to the third times q squared. All right, and that's my answer, and that's what I need. Okay, now, okay, that's it on that one. All right, so now let's look at all these. Okay, all these have negative exponents. All right, and so if I have 4 to the negative 2 power, I'm going to put this over 1. And what I kind of think about, again, is I take this and I move it down into my denominator. So this is going to give me 1 over 4 squared, and that's my answer. Okay. On this one, same kind of thing. I put this over 1, all right, because it has a negative exponent. I'm going to move it down into my denominator. I'm going to write this as 1 over, and this is the quantity negative 3 squared, okay, and that's my answer. Okay, on this one, m to the negative third power, okay, again, I'm going to put this over 1. All right, take this whole value, move it to my denominator, and make it positive. So this is going to be 1 over m cubed, and that's my answer. Okay, over here, now this is where it gets weird. All right, so I've got a times b to the negative 1. Now, let me rewrite this as a times b to the negative 1. Okay, now only the b is raised to the negative 1 power. All right, now again, I'm going to put this over 1. Okay, and I'm going to take this, and to make it positive, I'm going to move it down into my denominator, and I'm left with a divided by b to the first. Okay, I don't need to write b to the first. I can just then write this as a over b, and that's my answer. Okay, all right, let's take a look at this one over here. Now this one, notice how x to the negative third is in my denominator. I'm going to take this value and move it into my numerator to make it positive. So this would be x cubed over 1. Okay, we don't really need to write our answer as over 1, so we're just going to write it as x cubed is our answer. Okay. Ooh, one more. Okay, 3c to the negative 5 power, same thing. I'm going to put this over 1. Only the c is being raised to the negative 5 power, so I'm going to move that into my denominator, and we're going to get 3 divided by c to the 5th. Okay, and that's it. All right? Okay, so we've got that. Okay, let's do these last few. Okay, and this is going to be, so this is kind of where it kind of just depends, all right, on how comfortable you are with this stuff and, you know, how well you understand it, okay? So what I can do is this. I can do this 2 different ways. Okay, I'm going to use the product rule first. Okay, so this is, I'm going to do one method. Okay. And so this is going to give me 7 to the negative third, okay, plus 6, okay? And so when I just go ahead and just add them together, negative 3 plus 6 is just going to give me 3. So this is going to become 7 thirds. Now another way that I could do this, okay, so second method, second method would be to do, if I have 7 to the negative third times 7 to the 6th power, I'm going to put this all over 1. Okay, if I take this value, 7 to the negative third, I'm going to put it down into my denominator. Okay, I can do that. All right, that's a legal move. So now what I've got is I've got 7 to the 6th over 7 cubed. All right, and what I'm going to do then is I'm going to subtract my exponents. I'm going to get 7 to the 6 minus 3 power, which is going to give me 7 to the third power. All right, so I don't, guys, I don't really care how you do this, but as long as you get the right answer and you're doing it correctly, okay, it doesn't matter. Now, a lot of these I can kind of just do in my head, all right, but if you're struggling, again, with showing your work, all right, then you need to go through these methods, all right? Now, on this, obviously the first method is a little bit easier, okay? These problems will get a little bit more tricky, and you'll have to use a bunch of different methods within one to get the same thing, all right? So kind of just depends. Okay, let's look at this example. I'm just going to do one method. I'm going to do x to the 4 plus negative 3 power, all right, which is going to give me just x to the first, which is just going to give me x, all right, and that's it. All right, over here, I've got 5 to the 4th divided by 5 to the negative 2. Sorry about the quality of this. But what I'm going to do here is I'm just going to go ahead and subtract these, okay? This is going to give me 5 to the 4th power minus negative 2, okay? And so then as a result, what I'm going to get is this is 5 to the 4 plus 2 power, okay? So that's going to give me 5 to the 6th power as my answer. All right, now you can do this, you could take this 5 to the negative 2 and bring it up here and then add them. Doesn't matter, okay? But just as long as you get the right answer, that's all I care about. Okay, this one, all right, and I'm going to put this as an exponent of 1 here. Now I'm going to subtract these. This is going to give me x to the 1 minus 7 power, which is going to give me x to the negative 6 power. But I can't write this with a negative exponent, so I have to go one step further, and I have to say that this is going to give me 1 over x to the 6th, okay, and use that negative exponent rule that we have, okay? All right, the next thing I'm going to do is this one. I'm just going to go ahead and subtract these. So I've got b to the negative 2 minus negative 3, okay? Be careful with your signs here. So this is really going to become b to the negative 2 plus 3 power, which is just going to give me b to the first power. All right, so negative 2 plus 3 is b to the first, so my answer is just going to be b. All right, and that's it. Okay, I know this video is pretty long, but and once you know your rules, okay, this can go pretty quick. All right, and again, if you can, the more practice you do, the more problems you do, the better you get. And so again, I can do a lot of these in my head, and I don't need to write out these steps all the time. Okay, please do what you need to do to get these questions right. Okay, I'm more concerned about that than the speed at which you can answer these. So please get started on your homework, and we'll see you soon. Thanks a lot. Bye.